Let's go ahead and look at problem number 8 from section 5.4. It states the formula D equals the square root of 3 times h divided by 2 models the distance d in miles that a person h feet high can see to the horizon. If the pool deck on a cruise ship is 84 feet above the water, how far can the passengers on the pool deck see? Write the answer in simplified radical form and then use the simplified radical form in a calculator to express the answer to the nearest tenth of a mile. Okay, so they give us a formula. The distance is equal to 3 times h. Notice h is how high a person h feet can, the d is how far they can see, and the person is how high the person is h. Notice on a cruise ship on the pool deck they are 84 feet above the water, so the h would be 84. So I'm already going to put in 84 and then divide by 2 to finish the formula. You can go ahead and reduce this to a single answer. You can do 3 times 84 divided by 2, which or you can just do 2 goes into 84 42 times, and then 3 times 42 is 126. Okay, or either way you'll get 126. Now, what we're going to do is we're going to go ahead and we need the answer in radical form. So we're going to go ahead and put it in as we got to break it down. So 126 is 2 times 63. 63 is 9 times 7, and 9 is 3 times 3. So square root of 126 is, the prime factorization is 2 times 3 times 3 times 7. 2 times 3 times 3 times 7. Remember the rule, if it occurs twice, it's a perfect square. So 3 times 3 is 9, square root of 9 is 3. The 3 comes out, 2 and a 7 are left, so we multiply them, and we get 3 times the radical 14. Okay, so that would be our answer in simplified radical form. That's the way they want the first part. So again, the 3's on the outside, the radical on the course, 3, and then the radical is the third one down on the left, the square root, and then 14 goes under the sign, and we get our answer. And now to use the calculator, you can do the original square root of 80, what was it, square root of 126, or you can put in 3, and then second, remember x squared gives you the radical. It'll automatically multiply. And then 14's underneath the radical, and you get 11.222249 to the nearest tenth, 1 decimal place. The hundredth is a 2, so we would keep it at 11.2. And you could have also just done the radical without simplifying it. What was it, 126, I believe? Yeah, the square root of 126 is your 11.2249, so on. All right, very good. Okay, let's just get this one wrong. Let's get a new answer here. Okay, now. Okay. Oh boy, we need another answer. I'll just do it wrong. Okay, now we're just going to do a similar exercise so we can start over. Okay, we just want to start over fresh. Okay, the graph shows the median height for boys of various ages in a particular country. This is problem number 9, from the birth through 60 months or 5 years old. Compute parts A and B below. Use the graph to estimate the median height to the nearest inch of boys who are 45 months, okay? So 45 months is halfway between 40 and 50, right? So it's that line right there. We're using the graph. So this line right here is for 45, right? And it goes to about right there. It looks like it's a little bit less than 40, so maybe somewhere around 39. It's in increments of 2. So I would ask somewhere around 39. So let's go ahead and put that in and see if we're correct. Okay, it did mark it correct. All right, B, the formula h equals 2.9 times the square root of x plus 20.1 models the median height of h in inches of boys who are x months old. According to the formula, what is the median height of a boy 45 months? Okay, so now we put in the formula. So we can, obviously we need to use our calculator. We're going to get decimals, so we're going to use a calculator. So it's 2.9, and then times, it automatically multiplies, so you don't need to put a times. The square root of x, which is the number of months, which in this case it's 45. Okay, use your right arrow key to get out of the radical, right? The radical ends there, you see it? And then plus 20.1 is the rest of the formula. There it is, the formula right there. Hit enter and round to the nearest 10, 39.55. 1 decimal place, we would round up to 39.6. Okay? How well does the formula estimate? Well, the one was 39 and 39.6, so very close, right? So quite well, because the value given by the formula is very close, right? They weren't exactly the same. One was probably, we said about 39, the other was about 39.6. So we'll say it's very close. Check our answer, and indeed we get it correct. Let's look at problem number 10. The graph shows on the right, the graphs shown on the right shows that the heads of several autistic children start out smaller than average and then go through a period of explosive growth. The data for one of two groups shown by the graph can be modeled h equals 2.6 times the square root of x plus 39, where h is the head circumference in centimeters at age x months from 0 to 14, complete parts A through D. According to the model, what is the head circumference at birth? So again, the model here is h is 2.6 times the square root of x plus 39. The x is the months, and at birth, of course, the month is equal to 0. So x equals 0. So it'll be 2.6 times the square root of 0 plus 39. Square root of 0 is 0. Any number times 0 is 0. So 0 plus 39. The arithmetic is very easy. Faster to do with pencil and paper. So it would be 39. Okay? So at birth, we would get 39 centimeters. Okay, according to the model, what would the head circumference be at 9 months? Okay, so at 9 months we have 2.6, the square root of 9, which you can evaluate as 3 if you want, but you can just use your calculator, plus 39 for the rest of the formula to the nearest tenth is 46.8. According to the model, what is the head circumference at 14 months? The model is the formula. So again, the formula, we would use 2.6 square root of the number of months. In this case, it's 14. Get out of the square roots. So you use the right arrow. And then the formula finishes with plus 39. And we would get 48.728 to the nearest tenth, 1 decimal place, is going to be 48.7. Use the values obtained through parts A and C and the graph above to determine if the model describes healthy children or severe autistics. Okay, at 14 months, we got 48.7. So 48.7, you see here at 14 months, is going to be obviously a little bit below 50. So the blue one is below 50. The autistic is above 50, right? So for 14 months, it's definitely closer to the blue, which is the healthy children. So it appears that this model describes the healthy children, at least for what we got the value for 14 months. Very good. After an accident, police can estimate the speed Number 11, after an accident, the police can estimate the speed of a car was traveling by measuring its skid marks. The formula is V equals 2 times the square root of 5L can be used where V is the speed in miles per hour and L is the length of the skid marks in feet. Estimate the speed of a car that left skid marks 240 feet long. Okay, it's in decimal form. So since it's in decimal form, we can go to your calculator. Okay, it's 2 times the square root of 5 times L. There's the formula. And L is the length of the skid mark, which is 240. So we just put it in 2. And then what? We got second square root. It's automatically going to multiply. 5. Now here we put in what? L is 240. So we put in 240. And that's the end of the radical. And so we go ahead and hit enter. And we get to the nearest tenth, 1 decimal place. 69.28 would go to 69.3 miles per hour. The 8 would round up. All right, and if the posted speed limit is 50 miles per hour, should the officer believe the driver's claim that he was not speeding? No, right? Because he apparently, according to the formula, he's going 69.3 miles per hour. So no, the driver's estimated speed is clearly above the speed limit. All right, again, we just put into the formula, we needed a decimal. The formula is right here, V equals 2 times the square root of 5 times L. And L was equal to 240. And so we simply used our calculator. Number 12, the average height of a boy in the United States from birth through 60 months can be modeled by y equals 2.9 times the square root of x plus 20.01, where y is the average height in inches of boys who are x months of age. What would be the expected difference in height between a child of 49 months and a child of 36 months? Well, what do we have to do? The difference is subtract, right? So we have to find, we put in the formula for 49, right? So we're going to put in 2.9 times the square root of 49 plus 20.1, get an answer. We'll do it on the calculator. Then for 36, 2.9 times the square root of 36 plus 20.1 gets an answer. And then what are we going to do? Find the difference. So we're going to take the answer here, the first answer minus the second answer, and that will give us the difference, our final answer. Okay, so there's the game plan. Let's go ahead and do it and see what we get. So the first one is 2.9 times the square root of 49, get out of the radical, plus 20.1. There's our first answer. Then the next one is 36 months. So 2.9 times the square root of 36, which you know is 6. So if you can just put in 6 if you want. But anyway, the calculator will do it. Okay, and there's our second answer. Now what? Find the difference. So we're going to subtract. So 40.4 minus 37.5. The difference is 2.9 inches, which is obviously answer A. Okay, we're going to stop this session here. If you have any questions, email me at tswerz@hodges.edu, TSWIERSZ, or call me at 239-938-7805. Thank you.